So they hosted us, and we are also using their platform currently to do the meeting. And so this is part of our efforts to keep the community going as we continue to find more ways to engage ourselves. So without further ado, I'd like to introduce Calvin, and he can pick up, and then when you're ready, you can tell us, Calvin. Feel free.
Good morning. Can you hear me?
Yes, we can hear you, Calvin.
Yes, thank you, Avi, and thank you everyone who has gotten time to join this. So my name is Calvin Otieno. I will be taking you through some discussion here on in using Terraform and also HashiCorp Vault for your secret management and how you can integrate that within your pipeline. That one including GitHub tools, and the GitHub tools that we will be talking about here is Argo CD. So I think I presented this one last time in our open infra call or open infra day that we had organized by Abby and team. But I know the time is enough during that time, and now we had to schedule another one so that we can go through this and understand everything end to end. So I think that's all from my end, unless there is something that Abby wants to add before we start.
All right. Just if you have questions, feel free to add them in the chat. And then when Calvin is ready, he can answer them. And maybe depending on how you want to structure it, you can take questions at the end or at whatever point you feel you want to. So that's just the only addition. So when you're ready, Calvin.
Okay, thank you, Adi. Just a minute, I'm sharing my screen. Okay, so let me know if you can see what I'm sharing.
Yes.
Okay, thank you.
Can you make it full screen? Or
Okay,
a
okay.
slideshow?
Let me expand. And now? Oh no, let me expand. No. That one is going to give us. And what about now?
Yeah, it's okay. It's visible. So
Can you see my writings, or it is not visible? If it is not visible, just let me know. I will try to get it visible. Is it visible on your end?
can you go to another screen, because this one has big font?
This one has big fonts.
Yeah, so let's see, maybe another screen that's not the main screen. You see we can see.
Okay. Just let me do that. I'm sharing from my desktop. Maybe that's the reason why. Let me default this. No. Let me know if this other one is not that big. What about this?
Yeah, that's much better.
I will try to minimize it so that you get. And this one, let me try again. This one?
Yeah, that's okay.
Okay, so I've already introduced myself and what I do. So my daily job is on cloud and DevOps engineering. And then what we want to discuss today is on Vault and also a bit of Terraform and GitOps and a bit of integrating the same in your pipeline. Feel free to interrupt me in between if you have any question, and if you have anything to ask me, I will be able to answer that. Then now, what is Vault? Vault is an open source tool used for security, for securely storing and managing secrets. And with Vault, you can manage several secrets. It does support majority of secrets. Majority of them are open source, but some you will only get on Enterprise Vault. I think for the ones that we are using on our daily job or configuring our environments and applications, those ones are open sourced. In any case, you need to go beyond that is when now you go to Enterprise Vault. And then what are secrets? So secrets are securely sensitive or personally identifiable information like database credentials, SSH keys, usernames and passwords, anything name it, including your AWS credentials like the secret key, the access key, and also including anything to do with API tokens, including anything to do with credit card numbers. Those are categorized as secrets. Then why do we need to care about secrets? So one of the reasons why we need to care about secrets is how can we manage access to these secrets. So at one point or another, you have interacted with secrets, and maybe in your company or where you are working in, you find that most of the time people do share these either in Teams or in WhatsApp or in any other platform that they use within the company for their collaboration. And this means that anyone within that channel or everyone within that group that you are sharing this secret do have access to them. So you need to care about who or to control who do have access to these secrets, because once they are leaked, that will compromise your applications and also we put the company in a very bad state. In any case, this one goes beyond the company. Then also you need to care about who manages them. So you don't want everyone within the company or within the place where you are working in to have access to all the secrets that your application is using, or where you are deploying your applications. So you want to make sure that you have one person or you have a team dedicated to manage these secrets. And you also want to manage where these secrets are being stored. Then also, how do you control the access to these secrets? As I said, in number one is that you can share these secrets via any other channel that you want to share them. Some of them you can bake in code. I know at one point we did bake some secrets in code, and maybe for databases, usernames and passwords, or any other secrets like API tokens, and we end up pushing them to our GitHub or any other code repository that you are using. And you need to care about how you control those access, because once you push them to any of the code repository that you are using, or control any version control system, then anyone working within that version control system will have access to those secrets. And another thing that you want to care about is how do your apps get them. So if you are working in any containerized environment, maybe you are working in Kubernetes environment, we always define secrets by either creating a secret file and then within our values file, if you are using LCHARs or if you are using a naked deployment file, you can have those secrets defined there, and then you just deploy your application so that your application do have access to your secrets or to where you are storing your secrets. So maybe if you are storing them in, you have a database password or a database username, then you can just grab that wherever you are storing them and have them in your application code. Another one is on the Docker files and other artifacts files. You may have in your Docker file, you have baked something there, maybe Google application credentials, and you are using them to either authenticate to your cloud provider. You have baked maybe AWS access and secret key there to access. Make sure that your application do get access to your cloud provider. So you need to care about that, because if you bake, anyone who will have access to that Docker file will be able to see those secrets. And as we all know, with only a Google application credential, anyone can be able to authenticate to your cloud provider. The same to AWS secrets and API and secrets and access tokens. Then another thing that you need to care about is on how do you update them and how often do you update these secrets. Many times you use static secrets, especially for the credential that we want our applications to get access to, and even for human authentication. So maybe you want to be granted access to, let's say you have some virtual machines, you want to do either RDP or you want to do either SSH. So you will be given static credentials. So you will be given either SSH keys, which are static, and then you use these ones to SSH to these virtual machines. So with SSH key, even if you are if with SSH key, if they are not deleted, then you will have a long-term access to those virtual machines. So you need to care about how do you update these credentials. Another one is on the either usernames and passwords and API tokens. Do you generate them dynamically or do you give these as static credentials? So you also need to care about that. Then how are they revoked? So you need to make sure that once someone who do have access to a specific application, or whether your application needs to get only access within a specified time period, how do you make sure that after that your application will no longer have access to that environment or to those secrets? How do you revoke them once maybe someone within the company no longer need access to those secrets? So you need to care about that. How are they being revoked? And all these with HashiCorp Vault, you can control all these. You can control generating dynamic secrets. You can control updating and maybe controlling the access to these secrets, maybe not generating static SSH keys, but instead of that, using HashiCorp Vault to manage access to your virtual machines and anything that needs to do RDP or SSH. You can use Vault to also vendors that you are using, that you are working with, needs to either access your environment or to either access your applications. Then let's look at what are the problems that Vault helps us to solve with secret management. One of the goals of Vault is to act as a single source of truth for all your secrets. So you don't want to have your secrets everywhere. You want to have a specific place where you can go and either update or check and either revoke those secrets. So Vault will act as a single source of truth for all your secrets. And then how do you manage encryption, maybe at rest or at during transit? So Vault also gives you this out of the box, how you can do encryption during transit and at rest. And also, how do you generate dynamic secrets, which are just proved to be very hard to many people. So Vault gives you this capability to generate dynamic secrets, and we will see this in this demo. We will see how we can actually see how Vault can be used to generate dynamic secrets in our pipelines, and how we can use those dynamic secrets to integrate with Terraform and have a secure pipeline to deploy to any or to create any resource within our cloud provider. And also, how do you manage lease and revoking secrets? Also, this one we will see how you can use Vault to only give a specific amount of time to a specific secret, so that once the lease is over, then we are sure that that secret is no longer usable. And even if you have access to it, you can no longer use that secret to do anything in our environment. And also another thing is on the audit trail for generating and using secrets. You want to understand that, or you want to know who is having access to these secrets. You want to do the auditing part, and also you want to make sure that you can use this audit or can use this audit log or trail to make sure that even if in the event of anything happening, you can see what happened and why it happened and where it happened and who really did that. So maybe an intruder or something which is not supposed to access your secret and tried to access your secret. So all this is made possible by HashiCorp Vault.
Calvin,
Yes.
maybe before you continue, you can answer some questions. There's an interesting conversation happening on the chat. So maybe you can answer and then we go on, if that's okay with you.
Yes, let me just check. Thanks for that. I was not even seeing this one. I was focusing on the. Okay, so why don't you just use the .env files for the secrets? That's a very interesting one. I know for the .env files, let's talk. Maybe you are deploying using a Docker Compose, or if you are any developer that has interacted with maybe Flask, or you have interacted with Laravel, you always define these secrets in a .env file, and then during your Docker build and anything, you bake this into your Docker files. Why this is very dangerous? If an intruder get access to your environment or get access to either your Docker container, then it means they will have access to everything. Just have a .env file and have them there as secrets. Number two, if you have a .env file, then it means this .env file, at one point, you will have to push it to your production environment. Okay. Yes, and number two is from Denson is saying that HashiCorp products are no longer open source. Yes, that's true, especially for Terraform. Terraform is open source to up to version 1.5. After that, because they realized that people are trying to use it for commercial or to develop competitive product, now they changed that after they being acquired by IBM. So Terraform is still, no, HashiCorp products are still open source. Like Vault, Vault is partly open source and partly enterprise, not open source. So you can use Terraform up to version 1.5 still. You can still use HashiCorp product. If you're not developing a competitive product against HashiCorp, you can still use that. There are some other tools that are being developed. Like for Terraform, we have just forgetting the name, but we have an open source Terraform that has been forked from the original Terraform, and we are currently using that as open source Terraform. So the logic still remains the same, and everything still remains the same, and even the maintenance of this other open source tool are still from Terraform side. So you can still use that. That's a disclaimer. That's a very good insight. HashiCorp products are no longer open source if you are using them to develop a competitive product. Does that answer your question, Denson? I can't hear you. Okay, thank you. Then sharing credentials and passwords via WhatsApp is quite common. Thanks for that. They changed their license. You need yes. That's true. They changed their license, and I think actually need to. I was supposed to make that disclaimer before I start presenting. The disclaimer is HashiCorp products are no longer open source if you are using their products to develop a another competitive product. So they changed that because they realized many people were using Terraform and other tools to do that. Yes, thanks Ian for that. Yes, thanks for that. Actually, the open source tool for Terraform is OpenTofu. So you can still use OpenTofu. Everything remains the same, like the logic and everything still remains the same. So you can still use that. Okay, let me continue. So we will go into GitOps, and I will explain what GitOps is. So what is GitOps? GitOps is a continuous delivery strategy where you treat your applications and configurations as code, and you store them in a central version control system like Git. with GitOps, you treat Git as your single source of truth. So what we mean by that is what we mean by that is that any changes that are coming into your environment or any changes that is coming to your infrastructure deployment, you treat Git as the only single source of truth. So any manual changes will be treated as how do I put it? Will be treated as out of truth, something like that. Let me just put it that way. Any manual changes within your environment will be overridden if an apply takes place after the sync. So it means if you want to do any changes within your environment, the only place that you can do those changes needs to go through Git. So let's give an example. An example where you are deploying your application to any of your environment. In this case, let's talk of you are deploying to AWS, and then at one point or another, there's something that happened within your environment, and you go there and do some manual configuration. So you go there and either edit the deployment or edit a secret file. Then in that case, GitOps tools will identify that as out of sync and will try to check whatever thing that you have in your Git against what you have in your infrastructure. If they compare the two and find that what you have in your infrastructure is totally different from what you have in your Git repositories or Git repository, then it will identify, then it will tell you that there is something which is wrong and your changes or your infrastructure is out of sync. So that's what GitOps is. It treats your Git as a single source of truth. Instead of manually managing your environment, you manage your environment or you manage your infrastructure configuration and application configuration as code. I will be checking any question that is coming in, so I will be able to answer them. Then why do we need to use GitOps? So GitOps always help us to do safer and faster deployments. The reason we were talking about out of sync and making sure that you treat your Git as a single source of truth is to have a safer deployment. You don't want to have something that has been changed within your infrastructure or within your application manually. You want everything to go through Git so that it can be reviewed. You can do audit trail. You can know who changed what. You can do a Git blame and all the other stuff to understand what is happening there. And then with faster deployments is where you don't need to start editing things manually. You just need to push and then you let the tool do the deployment for you. Then ease of performing rollbacks. GitOps like Argo CD tool give you a way to roll back your deployments in any case you have any issue that is coming up, or in any case that is a problem that is coming up within your environment. So you can easily roll back. I know you can do a rollback with kubectl and other stuff, but with GitOps you can either use the UI to do a rollback or use a CLI to do a rollback, and this one will perform in a safer way. Then what I was talking about is better traceability. I was saying that you can know what happened. You can do a Git blame, you can do auditing and trails, and understand what really changed within your environment. If there is anything that is happening and it was not supposed to happen, you can still go back to your changes and check what really happened there. And then it makes it easy to eliminate configuration drift, what I was saying on the out of sync. manually manually making changes in your environment, it will detect that and tells you that this is what I've seen in your environment, and this is what I know from Git repository that you have. So it will tells you that and help you eliminate any configuration drift within your environment. People have really suffered with this, where something was working maybe 2 or 3 days ago, and then at one point you find now it is not working, and you can't understand why it is not working. Maybe you went there and made some manual changes, and the application started to resolve or started to work correctly. Then tomorrow, when you do another deployment, because you forgot the changes that you made, now the application is not working again. So that's what GitOps really helps you with, to eliminate. And then we will be talking about Argo CD. So Argo CD is a declarative GitOps continuous delivery tool, specifically for Kubernetes. And Argo CD is implemented as Kubernetes controller, which continuously monitors running applications and compares the current live state against the start target state, which we say that the live state is what you have running in your infrastructure, and the target state is what you have specified in your Git repository. And then if it identifies that the state has deviated from the target state, it will tell you that it is out of sync. Argo CD do have a good UI, which it will show you what is out of sync, and it gives you the difference by providing facilities to automatically or manually sync the live state back to the target state. Then these are the Argo CD features that you can use. It supports multiple configuration management and templating tools. You can either use customize, you can use Helm, you can use any plain YAML file. It also gives you the ability to manage and deploy to multiple clusters. It doesn't only support it doesn't only support one cluster. It supports multiple clusters, multiple cloud providers. So you don't need to use a single cluster per Argo CD. You can have one Argo CD managing multiple clusters across multiple cloud providers, even for your on-prem deployment. Then it integrates with a single sign-on. You can have any single sign-on and integrate with your Argo CD. It can perform for you the rollback and roll anywhere to any application configuration committed to your Git repository. It can perform health check status, analysis of your application resources, automate configuration drift detection and visualization. It can automate manual, both automated and manual syncing of your application to its desired state. It also have I mentioned that it has a web UI that you can use to give or to see real-time viewing of your application's activity. It has a CLI that you can use to automate and integrate with CI. It have a webhook integration, so you can either integrate with GitHub, Bitbucket, GitLab. It also have ability to do parameter overriding or parameters overriding. If you have an help chart that you need to override some parameters when you are deploying either to UAT, you don't want to use the same parameters to deploy to SIT or to deploy to production, it gives you the ability to override those parameters. Okay, before I move to demo, let me check what we have in the chat.
We have Sheldon's hand also raised.
Oh, yes. Let me just answer Can some secrets stored in HashiCorp Vault can be compromised? Yes. So Vault is only secure when also you secure it. So you can have a very secured environment, but an environment is only secured when also you secure it. So if your Vault environment is not secured enough, it also will be compromised. An example is where you have, when you are maybe initializing Vault, for those who have interacted with Vault, if you initialize Vault, it gives you what we call the root key or the root token, which is the default login when you first initialize Vault. In this case, if you do, if this root token is compromised, it means that your Vault environment will be compromised. So even for Vault deployment and setting up your Vault environment, you need to be very sure that the environment is being set up securely, and any other root access to the environment is revoked. So the root token, once you initialize Vault environment, you need to revoke the root token. And also when you are initializing the environment, you need to make sure that you don't only have one person having access to this key. So you can initialize this environment and distribute these keys among different users, so that not only one person have access to the environment to either unseal Vault. So we'll have a group of people, maybe 3 or 5, who will have access to these unseal keys and can unseal Vault. So when you distribute it, it means you are minimizing you are minimizing the attack phase in case of generating another root key to log in into Vault. Yes, Denson can ask your question now.
It was Sheldon. I don't know if he's still in the chat.
It's Sheldon. Okay.
Okay, I'm thinking maybe he's dropped out, but it's fine. You can go and then we can answer him later.
Yeah. Okay. Just a minute. So let's move to demo. But you can still ask your questions as we continue. I said that the demo
Sorry, Calvin, we lost you.
Okay, I think there is a problem here. Can you hear me now?
Yes, you're back.
Okay, thanks. So what did you hear last?
The demo.
Okay, okay, sure. So what we will be doing today, or the demo that we will be having today, is on integrating HashiCorp Vault within your pipeline. I will be demoing this with GitLab, but the same can apply to GitHub. So I will show something on how to also use that in GitHub. We will be seeing how. Hello, and I think my microphone is.
We can hear you, Calvin.
Okay, why is it giving me a muted button?
I don't know, but we can hear you.
Okay, let me continue. So we will be demoing that with integrating it with the AWS cloud provider. The same still can apply to any other cloud provider, either if you are using Azure or if you are using GCP, the same will apply there. Or if you are using either if you're using any other cloud provider, but I've mentioned the top 3, so the same will apply there. And then we will see also how to do now Argo CD and how to deploy the application with Argo CD. After that, we will see how you can pull secrets with Argo CD, or you can make your application to pull secrets from the Argo CD side and integrate this with HashiCorp Vault, so your secrets can reside in HashiCorp Vault, and then your application will be able to get these secrets from HashiCorp Vault. So in this case, you can either use any other tool, but the demo part is focusing much in using what we call external secret operator. So we will be using that to show how your application deployed in Kubernetes cluster can utilize HashiCorp Vault with an external secret operator to pull secrets and now give these secrets make these secrets available to your environment. Okay, so now I can see we don't have any other question here. So let me proceed. Let me share the whole screen so that we can see. Just a minute. Which one is this? Okay, let me share this. So let me know if you can see what I'm sharing. If the fonts are too big, let me know. I will minimize them. Are they visible or they are too big?
We can see, but they are small.
They are small. Okay, this one now at least they are small. And now?
Perfect.
Okay, thanks for confirming. So I have a very small application here. I have a very small configuration in this repository. This repository is also available in GitHub. I will be able to show you where you can get them in GitHub also. What this demo in this episode focuses in, I will still go back to my VS Code and show you how that code looks like. But in this case, I can just open it here and show you that. So this repository have some configuration. It has a configuration containing Flask application, a very small Flask application that is only connecting to a database. It also have this other folder called PG instance that contains all the Terraform code to create a demo Postgres instance in AWS. And then it has a GitLab CI file that is used to that we are using here to configure the CI. So that's what in this application. I will not go into details what the Flask is and anything because the demo here is supposed to focus on how to utilize Vault and how to generate dynamic credentials in your pipeline. Then I will go here into this other folder where we have the PG instance containing the Terraform code for creating the Postgres instance. We go to main.tf file. If you have used Terraform or if you have used OpenTofu, you will understand this code. It has some other things here which are very bad. I wanted to show this so that we understand what I meant by exposing your secrets in your GitHub repository or in your code repository. So this is an example here. where we have the Postgres user password, and also we have the Postgres DB name. Anyone with access to this will be able to have access or to know my password and know my DB username. These ones you can, if you have a Vault environment already configured somewhere, you can have your Terraform pull these from Vault instead of having them static here. You can also have your database generating these password and username, especially the password part, or if you want also to make the username to be dynamic, you can have that within your environment to be dynamic instead of having them here static. Then if I come down here, there is something here from line 45 to line 56. In line 45, what I'm doing here is I'm generating, I'm getting credentials from Vault, and this is an STS type of credentials. So I'm trying to assume some roles somewhere in Vault or in AWS, and then use this role to get for me some dynamic credentials. In this case, I'm using a backend role. I will show this where this is coming from, and also I'm using a type of an STS. Then my provider here is AWS. So if you have used Terraform or OpenTOF, you will understand this. Where if you have been deploying to if you have been creating your infrastructure in AWS environment, then most of the time you will have your access key defined here and your secret key defined here. And many times you will not even have this token here. You will only have these two environment variables defined: access key, secret key, and also maybe the AWS region. And this will be static. So you have generated them from AWS environment, and then now you either store them either in a secret static secret somewhere. Then you let your pipelines pull those secrets, maybe from GitHub secrets or from GitLab secrets, from GitLab environment variables, and have them during your pipeline run. That's what we do many times. And then what this repo do will only create a VPC. It will create for you. Then after that, you will define some other resource config here for creating the subnet. That is a DB subnet group, AWS security group for the Postgres, and now the instance part. This is just a Terraform code, and if you have interacted with Terraform, you will understand this. So what all these are. That's what this Terraform code does. But our major focus is on this part where you want to see how we can generate these credentials from Vault instead of getting them directly, or instead of generating static credentials from AWS side, something like that. Then there is something here that I wanted to explain. When you see this line number 41, you see that I'm defining an address here where I'm defining my Vault address. So this is my Vault address, which I'm storing as a variable somewhere. This Vault address, I will show you where it is being used so that you understand how all these are integrating together. Allow me to go back. I will go back to the GitLab CI file. If you have used GitLab, you have seen something like this, a CI file for GitLab. Then I will come to line 25, I'm using what we call an ID token, and then this is a Vault ID token. And the audience here, I'm putting in my Vault address, which is coming from an environment variable. Then under the before script on line 31, I'm generating a token and exporting this token, which is the Vault token. So what I'm doing here, I'm just doing a Vault write. Then I'm just doing a auth JW token, which is my role path, the path of my role, where my role was has been created. Then I'm just giving my role name, which is coming from like the var pipeline Vault role, coming from line 21, and then I'm inputting this one. So this Vault ID token is coming from this ID token, which is checking on my environment variable, which is audience for my Vault address. Once that, then I can check the token lookup to see what that token is. So the token lookup will give me the details of my token, including all the policies that have been given to this my token, and also including the TTL and the max TTL. So the TTL is how long will this token be available to be used. It also gives me the lease period, how long will this token be available to be renewed with the lease ID that this token will be given. All those details I will check with my token lookup. Then I will do a Vault write again to check, just to pipe what I have here with the JQ, just to check details again through by piping it to a JQ. Then after that, I will just do some random stuff here. Don't bother much about this. They're just there to check what my token is. After that, because this token, I know once I write this, once I get this token, then this token will contain for me some dynamic credentials, not static. So I can still export those credentials here to use in my next stages. In this case, I will just use that and use JQ to pipe that and get my data, export both access ID, expose access ID, key access key ID, secret access key, and then also export the session token. If you have interacted with AWS, you understand what this session token is. So your credentials are being given a session. So once that is done, the token will no longer be available, or the secrets will no longer be available for you to use. Then after that, I know after exporting those, then I can now use those credentials to either log into my my AWS environment. This is a Docker login, so I'm just doing a Docker login here to my ACR. After that, I will still use, so this is an helper stage. I use that helper to now, instead of defining all this here, I can now use this helper here. Like for my build and push, we'll use that helper, and then I will do my Docker build, and then I do my Docker push. The same too, I can use that helper again. I can use my I can now do my Terraform init and do a plan, and then I can do the same to all other stages here where I need to do this the apply, and if I need to do the destroy part. If you see here in line 68 and some other lines below here, like line 80, you will see I'm exporting this one here, which is the Vault address, and this Vault address, you saw it in my provider, the other side. So in my Terraform code here, you see here, what I have here is a provider vault address. I need this vault address so that when I'm getting the token from AWS, and when I'm configuring my OIDC side in my pipeline GitLab CI file, then I can have this vault address available. And if you can see very well, we are not defining any other thing. We are only defining the vault address. We are not even defining the vault token or any other stuff, or the vault token we have generated somewhere. We're only defining the vault address, and with the vault address, the vault backend, and the role name, we can now generate these dynamic credentials and use them in our pipelines. So before I show you any pipeline, okay, no question, can continue. Let me come back here. So let us go to one of the pipelines. I will start with one which passed some time ago. Let me go to 1 hour ago. I was trying to run this 1 hour ago. I will go to this one, which has a plan. This one passed, and I will try to explain, or not, I will explain to you why this one passed and this one failed. The other ones failed. So this one was running a plan, and you can see what the plan is. You know, if you have interacted with Terraform and OpenTofu, you will understand what this plan is. And it tells us that we are going to add 3 resources, do a zero change and do a zero destroy. What we are adding is here. We are adding an AWS DB instance. We are adding AWS DB subnet group. We are adding security group, and also we are adding those 3. We are adding those 3 items there. So this one was a successful run in our pipeline. But now, after that, we had a failed one. And if we go and check here, there is a failed one here. The failed one was reading EC2 VPC, and it's telling me that you are not authorized to perform this operation. So user, and you can see this user here is having an STS. So it means this user is a assumed user. It's not a static user in AWS. This user here doesn't have access to perform EC2 describe VPC because no identity-based policy allows EC2 describe VPC. We will come to know why that is happening. Allow me to scroll up, and I will explain those stages that we had. I was showing you in my GitLab CI file. This is the stage where we were doing a write to vault and to this path, giving my role, and now passing my vault ID token, which is GitLab defined environment variable for GitLab. So these are default, like a default GitLab defined environment variable that you can use to integrate for ID tokens. Then after that, line 28, I'm doing now vault token lookup. And if you can see here, this is my token. You can see creation TTL. The creation TTL is amount of time. This is time to leave. Amount of time this token will be available for use. And it also gives me the expiry time. You can see, you can calculate how long when you was running this pipeline. It should expire today. Actually, it already expired because it was only for 10 minutes. No, the max TTL is 15 minutes, so it was only available for 15 minutes. It also gives me the where's the lease? So the token is renewable, so I have it must have a lease. So if I come down here, I think that's where I will see what I have for the lease. I have my token, the lease ID. Still I've not given this token, I've not renewed it, or I've not done anything. But now I can see I have the client token, and this client token is what I will be like once you log into Vault with your role. It also gives you a token that you can also log in in Vault. Then down there, it gives me all the policies that I have attached in this token, and that includes the Argo CD helper pipeline, and also another default one, a default policy that is created when you create Vault. It also gives me the entity ID and list duration. So how long can I renew this token? So for this one is 600 seconds. So you can calculate how many minutes are those. I think this one should be 10 minutes. So you can have a lease period of 10 minutes. Then if I go down here in line 78, I will see if I pipe that to JQ, then check on my data part, I will see I have the access key, which is the AWS access key. I have the ARN, which is the role ARN of the user, that is of the role that is trying to assume this. Then I have also the secret key here, and I have the security token for this. So these are the environment, these are the values that we need our Terraform to have so that it can do an infrastructure provisioning. Then also we have the session token here, along for our generated credentials in AWS. After that, these are just other exporting this to what we have here. The access key, the secret key, and the session token is what we are exporting. The security token is what we are exporting here. And then after that, you can see after exporting those environment variables, because if you have interacted with the GitLab, this AWS access key, AWS secret key, AWS session token, these are like default GitLab environment variables. So you don't just do an export, and when your pipeline runs, GitLab will know what these are. And then after that, I can now try to authenticate to my ACR, which is successful here, you can see. And after that, I can go to my Terraform directory and do an init, then do a plan. After that, do an init, and then even before I do a plan, this is just in doing a Terraform init. Then before doing the plan, it's trying to read some data using what we have here: data, Vault, access, credentials, data, Vault, access, Vault, AWS access, credentials. Reading them from what we have here. You can see here is ID is Argo helper, STS Argo CD, with some random values that we have here. You can check it at the top here. Where is it? Argo helper role. Well, yes, this one here. Then it is failing because in one way or another, there is something which is missing, so it will not pass. Now let me go to my Terraform code and show you that. I will just open it in GitHub. This one is available in GitHub. The one for Vault, the Terraform code for Vault, why that is happening. Let me open it here. then go to AWS. I will share it in a minute. Then I come to Vault. I will come down. I was trying to share the whole window, but it's not happening. Okay, let me check what I can share. I will share the whole window now so that you see. So if I navigate, you can see. Can you see GitHub?
Yeah, we can see.
Okay, the fonts are okay. Okay. Then here, this is just my Vault environment that I've created. I will be focusing much on this side, this part here. So this part is where we have what we call AWS IAM role policy, which is the pipeline policy I'm using. And this one I've just given a name that custom pipeline policy, and it has a role, which is I'm creating here a role. And then it has some actions, and these actions are coming from a variable. If I go to this side of the variables, you will see that the pipeline actions variable here, we have all these defined. So we have, this is too much, but I'm just giving this because it was a testing environment. So you can still minimize this. Instead of giving all S3 access, you can only give maybe S3 maybe read-only access, or maybe you want to minimize this to only the access that you want to give. The same to DynamoDB, the same to EC2, the same to RDS. You can see for the cluster, I've only given the one for describing the cluster, and also for the ACR, I've only given the permissions that are only needed to push image to ACR. And I will come back to why this one is still failing the other one. Okay, so I will also try to explain something on the GitLab gwt.tf, and these are just a resource that is defining our GWT auth backend for GitLab CI, then where we are mapping that, and some other stuff here for giving the token some policies and what this token can do. Yeah. Then down here, we are still configuring the Vault policy using this, what we have here as the data. And then we are doing what we call creating a Vault auth backend. And this Vault role name is what we have here, var pipeline, var project name, then pipeline. And that's what we are using here. If you can go to our, no, not this one, but this one. If you can go to our GitLab CI file, you will see under this place, under the CI file, on this line number, you can see this is what we are using here, line 21, Argo CD helper -pipeline. Then we are just giving some audience access to this, and we are minimizing this to specific GitLab project ID and a specific branch, which is the main branch, and also giving it a user claim of user email. So you will see that my token do have my email there attached to it, my role for the user, user that which is assuming the role do have an email at the end. Then the token max TTL. Then after that, I'm just creating an auth backend, the AWS secret backend. The same will end up with also the pipeline at the end of it. And I'm also giving the role name that this pipeline will assume when running. That's what all these GitLab TF file is. It's just the same with the GitHub TF file, only that you only need to do some small changes to make the one for GitHub work. Okay, so let me come back. We'll try to get my screen for where I'm running these changes for the Vault. I'm running this locally for Vault, but the one we are demoing, I'm running in the pipeline. So why I want to show you why the pipeline is failing. Our fonts are a bit small. Okay, I will expand. Stop sharing. Then let me share something again. Okay, let me know if you can see my screen again, and that is for VS Code.
Yeah, just make the fonts a little bit bigger.
So I will increase and let me know. And okay, now
A little more.
and now.
Yeah.
Okay. So this is the same thing that I was explaining there, because I'm running this locally. So the reason why this is happening, if I uncomment this and deploy, then it means my pipeline will pass, because I will have EC2 access given, EC2 policy given here, or EC2 permission given here. So I will be able to do what was failing there, which was VPC. The scribe will now be able to pass, because I'm giving the permission here. You can still drill and give the smallest one that you need. At the same time, I've also commented this, then it means if it tries to do a DS deployment, then it will fail to do that because this policy will be missing. So let me uncomment this. No, I was supposed to share. Let me uncomment this. And then, where is that window? Let me know if you can see my terminal. I know it's still small.
Yeah, it's visible.
It's visible. And the fonts are good.
You can work with them. Yeah.
Okay. So you can see the one for Vault infrastructure, the terminal for Vault infrastructure.
Yeah. Yes, we can.
Okay. Just a minute. Just a minute. Just give me 1 or 2 minutes. I will be back here. Let me just do this. Okay. Let me. Okay. Let me do that. Share this. Let me know if you can see my screen again.
Yeah, it's back.
Okay. Thanks for that. Then here I can do Terraform plan. Let me just do a Terraform plan of Vault. And let me know if you can see the plan output after it is done running. Let me see. It is taking time. I don't know whether my network is okay. It is done. Can you see the plan?
Yeah.
Okay. So this plan here, you can see that EC2. I actually added it before we came into the call, but it means I already applied it with this one here. So that means it is already there. And this one is trying to remove it. So let us go back to our pipeline and run again. The plan should pass before I apply this, because the negative one means that something is going to be removed, which is the EC2 access. So it means it's already there. I applied it before we came into the call. So let me go back to the pipeline and show you that. So the plan should pass. So this is our, let me know if you can see the other tab for GitLab where we are running the pipelines. Can you see it? Okay. So let us rerun the plan again and see whether it can pass or fail. It should pass with the EC2 one, which was failing. Okay, the pipeline is too slow, but it should be done in a minute or so. It's really running, yeah, a bit slow because I'm using open source. Yes, so you see this one is passing. So the EC2 one is the one which was failing previously. Now we have another one which is RDS, because if you remember the code, we commented out the RDS one. So this one will fail because it is commented. So it doesn't have access. The user doesn't have access to RDS. So let's go back and comment the one for RDS and come back and rerun again and see. Okay. Now let's go back to RDS. So here I will uncomment the RDS one. Oh, even the one for EC2, because let me now comment this one so that we see the RDS one is passing and the EC2 one is failing. Okay, so I will go back to, I don't know why this is not giving me let me share this. I will go back and come back here and run a Terraform plan. I know, I hope you can see the terminal where I'm running the plan.
It's visible.
Okay. Okay, so this one should bring back for us the RDS. That's just a list. So how the list works in Terraform is a bit more different. So I will apply this. Let me do an apply of that, and then run the pipeline again. Some other inputs here that I maybe. Okay, this one doesn't need an input. So the apply is done. It has modified our policy, the pipeline policy. Let's go and rerun our pipeline again. It should be able to pass the RDS side and may fail on the EC2 now. So we run that. Let's see what happens. Okay, so you see the RDS one passed and the EC2 one failed. So allow me just to apply the one for EC2 so that we can see the pipeline green. I will uncomment that and make the pipeline green now. So let me uncomment the EC2 one. Terraform plan. Okay, I'm not sharing this, but let me share. Where is it? Let me share this window. Okay, you can see the one I'm sharing is the one for Terraform plan. And we see the plan output. So the plan output is we are adding the one for EC2. I will apply this. So the plus sign here means we are adding something. So it's complete. And then if we come back again, here I will try the pipeline. It should pass. The plan should pass now. You can take note of this. And now it passed. The pipeline has passes, and you can see because I've already applied these changes, so we don't have any change to be applied. So then your infrastructure matches the configuration, so no change to be applied there. So you have seen how we can integrate Vault with Terraform. So instead of having static credentials in your infrastructure, maybe you have the static AWS secret ID, access key ID, a secret key and access key ID. You can integrate that with Vault. If it is as one environment, like you are only deploying in one specific AWS account, you don't have multiple AWS account, you can still use what we call the OIDC in AWS side and integrate with your pipeline. It doesn't need to be Terraform. It doesn't need to be Vault. But in cases where you want to integrate multiple AWS account, you want to assume a role instead of having the static credentials. So you have either dev account, AWS account, you have prod AWS account, and you have maybe a SIT or UAT AWS account, or management and security AWS account. Then you can and you want to integrate with Vault, you can utilize Vault GWT now to make sure that your pipelines can have cross-account access with assuming role. Any question before we move to the next one? And if I've lost you somewhere, just let me know. Okay, I think we are good. So let us go to GitHub. I will just show something here in GitHub, how the same works in GitHub, a small one. Then we can move to the next thing. I know we are running out of time. And Abby, let me know if we are running out of time so that I can stop.
Yes, we are running out of time, but you can just finish up.
Okay, let me just finish up. No, not this one, but yeah, my GitHub where I can see that. Let me go to my repositories. Okay, let me go to this one here. Then let me go here to actions, and then let me go to this place here. Then let me go to IDC part, and also the same thing is happening here. You are logging into Vault, and you can see this is for GitHub. This is my audience, and I'm also being given a token here, a request ID and everything, and I have the TTL, something like that. I also have the policies attached to this particular token, and then I can use that token to read either secret from Vault. So the same thing happening here. My Vault is running in Kubernetes environment, so that's the reason why we have this. And also you have the audience and other stuff. Then I can read some secrets here. Then I can show that secret. So this secret is coming from my Vault, and it is just for showing the secrets for testing. You can see I can use the same token to read secrets from Vault and get the secret from Vault. So the same can apply to any environment, either Bitbucket, either GitHub, either GitLab, any other CI tool that you may want to integrate with Vault. It should work. So for the interest of time, I will just go over the deployment part, and this one, Abby, I will request you to give me another time when you will be available, so that I can go in deep into Argo CD when we get time, and how that whole thing is working. I experienced an issue here. If I go here, the helper, you can see when I'm trying to deploy, it can actually authenticate to my AWS account. You can see with that token that we are generating here, which is this one we are exporting here. I can still authenticate to my AKS cluster, and I can still get the caller identity with that token. I can still check my cluster by kubectl view minify. But unfortunately, when I try to do the helper deployment, it's failing somewhere here. So I need to debug that. It started to fail when after a few minutes to this call. Things like that do happen. So allow me next time to explain more how this one work, if that will be possible, Abby.
Yes, we can go deeper. I know people are a bit tired from work and whatever,
Yes.
and you don't keep people too long so that they don't run away from our community webinars.
Okay.
Yeah. So, but have you finished though, or have you covered what you needed to cover?
Yes, I've covered about I need to cover. Only the Argo CD part is what I'm saying. I haven't
Yeah.
covered the way I wanted it to cover,
Yeah.
because I wanted to explain now. Like if I go here, let me just go here just in a moment. If I go here, you see there's this application that I want to deploy
You're
with
not
Argo
sharing
CD.
your screen.
Oh, no. Sorry for that. So if I come back here, so let me know if the screen is visible. Can you see my GitHub?
Yeah.
Okay, so if you see this CD helper, the helper here should be able to deploy for us the application in Argo CD environment. And this application is this one here. So it should actually deploy for us our demo application, which is a Flask app that we have here with its Helm chart to the Argo CD environment. But as I said, under the authentication part, I have some small issue there that I need to figure out why it is not getting the API not the API, but not getting the cluster server API server even after authenticating and using the token that I've generated here to authenticate to my AKS cluster. It was just working. I'm not very sure. But if I go back to the old pipelines here, like this one here, you can see the one for the deploy first, and you can see the token that we are generating here, including these other ones, including authenticating to the cluster, including getting the nodes, including now the deployment worked. And we have an Argo CD environment here, which is now useless because we cannot deploy. But if we get another time, I know I will fix this, and I also will share with you in any case the team want to understand why how that is working and what was the issue. I'm done, Abby. That's all. There is no any other question.
So I don't know. Do you have any questions for Calvin? We have a question from Terence. Is it possible to be a DevOps engineer during the entry level stage of your career? Or is DevOps just for those who have vast experience? Terence asks.
No, DevOps. What I will say, because I know majority of people do say that for DevOps you can't get into DevOps in entry level. But I always say that it doesn't matter. You can still get into DevOps in your entry level. What I will say that it will need you to be able. It will need you to have some steep learning curve, because you need to understand many things. so that you can understand how applications are working. You don't need to understand everything within an application, and you don't need to understand how to code, but having that little knowledge of how applications are running or how applications are being developed, and you can understand some scripting, some fundamentals of scripting, either with Python or any other language like Golang, then still you will be able to get into DevOps in entry level. It doesn't matter. You don't need to have a vast experience to be into DevOps.
Okay. Any other questions? All right. So I assume we are quiet because we have learned a lot. Yeah. So thank you so much, Calvin, for taking the time to come and teach us about how we can manage our secrets better. No more keeping them in our code. And we now know .env files are not as safe as we think they are, even if we gitignore them. So I think this is a good thing to try out, especially if you work with pipelines and store secrets in somewhere like AWS, so that you can keep them safe and you can track what happened. Because I think also that's something we usually don't have. So without much further ado, we can end here. So thank you so much for being with us this year as the opening user group. Thank you. I keep forgetting you have this bracket. We can clap for Calvin, though want to visit in person. And yeah, so thank you so much, Calvin. Thank you for coming back and teaching us again, because the first time there wasn't enough time. We've recorded this hopefully. And so if you
Yes.
want to rewatch, you can always go back to it. So this is officially our last event of the year as a community. It's been an interesting year also. So thank you so much for being part of our community, and we'll definitely take a break and come back with hopefully better things next year. So thank you so much, Calvin. Thank you for everyone who joined. And I hope you've learned something that you can go even implement at work and even practice in your personal projects. So thank you so much, everyone.
Thank you.
Feel
Thank you.
free to drop out or stay and hang out wherever you decide.
Thank you. Yeah.
And
Bye.
we can keep clapping as we leave.